Good afternoon and welcome to today's webinar, Damper Actuator Sizing and Selection. My name is Michaela DeMarchi and I'm going to be your moderator for today's webinar. In just a few moments, our presenter will jump on the line, but I just want to talk to you really quickly about how the process is going to work. So Nelson Estrella, our presenter today, will complete the webinar. Then at the end of the webinar, we will have a question and answer session. So if you look to the right of your screen, you're going to see a little area that says questions. If at any time throughout the webinar, something should come up and you have a question, you can type it in that area or wait until the end. At the end of the session, I will read the questions out loud and then Nelson will answer the question as best as possible. This webinar is being recorded and will be posted to our website at a later time. And if you're interested in actually having the webinar link emailed directly to you, I'll give you some further contact information at the end. So without further ado, I'd like to present to you Nelson Estrella.
Thank you, Michaela. Good afternoon, everyone, and welcome to this 30-minute webinar. We'll be covering damper actuator sizing and selection. I'll be covering the fundamentals on how to help you properly size and select the damper actuator solution for your installation. So this will be very basic, and obviously this conversation can go into further details, but we're going to, like I said, covering the fundamentals to help you in figuring out what the best solution would be. So moving on, looking at the first application here that we see, it's a typical application that we've come across in the past, and actually where we assisted a customer in replacing some older pneumatic type actuators. You can see here, you can see the photos here on the left and on the right. I was showing a typical assembly we came across on an air handler, and the information that was provided to us in terms of the physical aspects of the damper. But of course, there are other conditions and other things that apply to it when you properly size the damper actuator. Now, the worksheet showing here are the basically 10 simple steps that will help you properly size and select a damper actuator. Now, these instructions can be found on our retrofit technical documentation and also online at our Belimo website. And of course, we always have a technical support staff on hand to help you with any other additional questions that you may not be able to answer through this worksheet. But like I said before, these do cover the fundamentals in sizing. Now let's start with the basics. Torque formula. Well, we start with the damper area in square feet times the rated torque loading of that damper, which would be in inch-pounds per square feet. Now you multiply these two, will get you the torque in inch-pounds that's required to operate the damper. So I mentioned the two pieces that we need are damper area and a damper torque rating of that damper. So first step, what's the total area? Well, in that first example we showed you, we had the height and the width. Either if it's already known, or you just take out your trusty tape measure and measure up the size of the damper or dampers. You determine that square footage either from inches and converting it into feet, or straight from feet into square footage. In this case, a 3 by 4 foot damper equates to a 12 square feet area. Now, damper design, that's very important. So step 2, we have to take in consideration what you're looking at. Either an opposed blade or a parallel blade. This also plays a key factor in terms of how much torque is needed to operate the damper. So in our case, you'll see that we have an opposed blade damper. Now comparing the two, an opposed blade, just like the name calls out, is damper blades are moving in opposite directions, which require less torques compared to a parallel blade type damper, where the damper blades are moving in the same direction. These will typically use more torque. Now, not only would the blade design play a factor, also seals. You could have edge seals on the damper blades and around the damper frame against the blades, which cause extra friction, which will lead to more torque being required. Now, going from steps 1 to 2, we know what the damper design is, basically the type of blade types it's being used, in this case, opposed blade, and we also know it has the seals on them. So now the torque loading with seals is 5 inch-pounds square feet versus An opposed blade without seals is 3 inch-pounds per square feet. So there's that difference right there. Step number 4, the damper manufacturer typically would provide this information. It could either be on a cut sheet, could be on a label stuck onto the damper, it could be on a blade or a damper frame on the side, but sometimes this information may not be available. Maybe that label's scratched off, it's just worn out, or just the information just can't read off the model of what that damper is. So if it's not available, you can use the square footage information, and using that, and also with the type of blade and edge shields, in this case that we have, we use torque loading numbers that we've had for many years, and that's been worked on and in association with a lot of our damper manufacturer customers, which become the typical numbers that you come across in the field. And in this case, in a typical HVAC application, you run into about less than 1,000 FPMs in terms of air velocity. Torque loading will increase as well if that air velocity increases. So that's another factor to take into account. In this case, we'll start off with the 5 inch-pounds per square foot at 1,000 FPM typical air velocity. Now, if you do not have the FPMs, and if you do know the CFMs, you can easily calculate that by just dividing that by the square footage to get the FPMs. Now, we do have these 3 different values for the less than 1,000, 1,000 to 2,500, and 2,500 to 3,500 FPMs. Now, if the application does have a higher air velocity, we do recommend that you work with the damper manufacturer to get some more information on how that damper would be affected by higher velocity. And that additional information will help us assist you in determining what the best solution could be. Now, going through steps 1 through 5, we've determined what the square footage is, which is 12, the type of damper, blades, and also the if it has edge shields or not, which determine the torque loading. And of course, the air velocity. So again, taking that typical less than 1,000 FPMs gives you about 5 inch-pounds per square feet. So 12 times 5 gives you a torque of 60 inch-pounds required to operate that damper in this configuration under these conditions. Now, let's say we take the same size damper and the blade construction is different. So the configuration instead of proposed blade is now parallel blade. So square footage is the same, but torque loading will change because of the configuration. So instead of 5, now it's 7 inch-pounds per square feet. So 12 by 7 gives you a number of 84 inch-pounds required to operate that damper. Now let's go one step further. Let's take same square footage, go back to opposed blade, but now the FPMs is higher. So square footage is the same. Now because of the higher FPMs, the torque loading goes up. So say 2,500 between 3,500 FPMs gives you about 10 inch-pounds per square foot. That results into a torque of 120 inch-pounds. So now it's a lot higher than where we started. Now, knowing this information, we move on to actuator selection. So now we've narrowed it down, what do we need? Well, if you're familiar with Billing Mill actuator offering, we have a spring return actuator line, starting with the TF series, which is the smallest at 22 inch-pounds, all the way up to the EF series at 270 inch-pounds. Or a non-spring return line also, starting from the LM series at 45 inch-pounds, all the way up to the GM series at 360. Now, step 6. The question is fail-safe actuation required? Now, looking back at those 2 lines that I showed you, will spring return be needed? In this case, it was. As part of an air handler unit, and they needed spring return because of the damper location being used for air intake. And up in the Northeast, we know that the conditions get really cold, and you want to prevent any air, really cold air coming into the system if there was a power failure, and to prevent any of a system damage, like namely a coil freezing over and bursting. So is fail-safe required in this case? Yes, it is. Step 7, power supply. Well, this is very important because if you don't have electricity and you don't have power to the actuator, it won't move. So in this case, it's a typical 24 VAC application. We do have line voltage models. Going through our catalog and also our website offering, you'll see that what we have in terms of different types of actuators and also in torque ranges. But in this case, 24 volts AC, 24 volts AC is a typical type of voltage that's used. If you don't have 24 volts AC readily available, we do have a transformer in our accessories offering that can help you get to that voltage. Step 8, in addition to the power, what kind of control do you need? You have the basic on-off, a 2-wire type control. You need either close or open. Floating point, which is a lower end type of modulating type control. You go either clockwise or counterclockwise or stay in place. 2 to 10 or 0 to 10 VDC control signal, which is a modulating type control, but directly proportional to a control signal. 4 to 20 milliamps, similar to a voltage type control, but in this case it's current. We also have a pulse width modulation, which is a time-based type control, or another type of control that could be configured through our MFT, which is our multifunction technology offering, which can be configured in the factory or in the field, depending on what your application is. Most cases, controllers are typically 2 to 10 or 0 to 10, but if you have something out of the ordinary, or if you have something particular, something like a sequencing type application, then we can tailor that control range through our MFT offering. But in this case, the customer only needed a 2 to 10 control input. One note for the 4 to 20 milliamp, our billion mile actuators don't have a 4 to 20 milliamp input direct. It only takes 2 to 10. So what you would need is a CGR01 kit, which is a 500 ohm resistor, which would just be placed in shunt from the input down to ground, which will convert a 4 to 20 milliamp signal to 2 to 10. Now, based on information that we've collected, knowing that we need fail-safe, we need a 2 to 10 control input, 24 volts AC, and the torque that was calculated based on information we gathered from the damper being at 120 inch-pounds, what actually would fit that criteria, which would be an AFB 24-SR. Now, the rated minimum torque is 180 inch-pounds. Has a 2 to 10 control input. Now, keep in mind the SR does not mean spring return. It's a Swiss German term that actually means a modulating and not necessarily spring return. It's all part of the nomenclature, which is another webinar that we can have and discuss further. Now, the AFB 24-SR is 180 inch-pounds minimum, so guaranteed through the life of the actuator. That's what the torque output of the actuator will be. There's your temperature rating in terms of ambient operating and also your control input. Now, the SRs typically also have a feedback of 2 to 10 as well, in case there is some monitoring to do, and also it depends on your application, which can be fed back into the controller. Number 9, the second to last requirement is, can this actuator be direct coupled? Now, depending on the installation, it could be an existing older installation where some of these actuators could be foot mounted with linkages, or if it does have a control shaft, either as a form of a jack shaft or on the side of the damper frame, most of these actuators can be direct coupled. Now, in this case, we were able to direct couple while removing those older pneumatics. But if you cannot, we do have different accessories that allow you to mount this actuator indirectly. And that could be in the form of crank arms, ball joints, and push rods. Now, in this case, we've got the direct mount capability, which was great. And the final solution, as you see in the photo, by removing the older pneumatics, the AFB 24SRs was successfully installed and properly wired, which is very important. Now, if you have other cases where you don't have access to the control shaft of the damper on the sides or through a jack shaft, it could be depending on how the damper was installed or if there's additional sheet metal around it, We do have different kits besides the mounting brackets and the indirect mounting kits that we have. We also have this jack shaft solution, which allows you to connect an actuator directly to a jack shaft while removing the jack shaft bearings. The open-ended design of this jack shaft linkage allows you to clamp onto a jack shaft diameter from 1/2 inch all the way up to 1.5 inches. And that open-ended design allows you to mount an actuator up to an EF in size, up to 270 inch mounts. So there's one solution that allows you to mount an actuator directly to a jack shaft if you can't do it from the sides. Last but not least, like I mentioned before, accessories. Besides the mechanical aspect of things in terms of connecting the actuator to the damper, we have electronic accessories as well. Some models you can attach in the add-on switches, potentiometers. We do also have other mechanical type accessories that allow you to attach to dampers, such as shaft extensions and different types of clamping devices. So in this case, since we can be able to direct mount them, we do not need any additional accessories, and no additional other electronic accessories as well, just like switches or anything else. Now, in terms of the type of installation or where it's being located, the actuators could come as standard NEMA 2, which is basically for indoor use, or NEMA 4. So we highly recommend to look deeply into your application and see what is required of our actuators. So depending on the location, say it is exposed to the outdoor environment, NEMA 4 housing or some kind of weather shield is highly recommended. As depicted here in this slide, we do offer the AFB24SR as a NEMA 4, which is shown with the N4 suffix, which is basically the actuator within a NEMA 4 rated clamshell. This allows for outdoor installation if necessary. And now the H at the end, if a heater option is required, the N4H comes with a heater built inside the housing with a thermostat that's already preset, which is adjustable as well, for a lower temperature operation and also condensation control. Now, NEMA 4 is not offered on every single actuator, but you'll have to consult our catalog, and also we also recommend contacting the LEMO for further information on what kind of models and what features are offered. And besides that worksheet that we also have a great online and offline tool, which is our Select Pro. Our Select Pro software is downloadable and can also be run by online through the website. Allows you to do exactly what we just did today, to properly size and select the damper actuator, and also go through our water side product as well. And also we have a retrofit section, which is very handy to do cross-referencing to competitor products, and to properly size and look at different features and the differences between our actuator solution versus the competition. And Bloom University is another great tool we will offer, and could also provide additional training to your staff, and where we can offer it online and offline. That's pretty much it. Hopefully this was helpful for all of you, and if there's any questions, we open up the floor. Thank you.
Thank you so much, Nelson. So while you are typing in those questions, we had some come through. I'll just give you a couple of moments. If after the webinar something should come up and you have additional questions, you can email us at marketing@us.belimo.com. So here's our first question. In your solution shown here, you use 2 actuators. Do you then cut the torque by half, downsizing the actuator then?
Now the solution, can you repeat that question again, Michaela? Sorry.
No problem. In your solution shown here, you use 2 actuators. Do you then cut the torque by half, downsizing the actuator then?
Well, in this case, actually, we showed one side of the solution. They actually had 1 pneumatic actuator per damper. So in that photo, and I'm not sure if it was seen, but there was actually 4 pneumatic actuators. So each pneumatic actuator was replaced by a single AFB. So we saw one side of the installation, so we had one AFB per damper, so actually 4 AFBs were installed. Now, based on the calculations, 120 was the required torque, so 180 was the next step up for torque in terms of the actuator. So there was no reduction in torque, or we didn't reduce the torque in terms of the configuration. So it was almost like a one for one. So 4 pneumatics were replaced by 4 AFBs. I hope that answered that question.
Okay. Next question, what solution does Belimo offer for explosion-proof actuator applications?
Good question. Going back to the housings, besides the NEMA 4s, we do have a NEMA 4X housing, which is the ZS300. Certain actuators do fit in as well. And we do have a ZS-260 explosion-proof housing. That's also in our catalog. And most actuators do fit, except for the EF being the largest of all the spring returns, does not quite fit in that housing. But the AF being the next largest spring return actuator does fit in there. We can also fit non-spring return actuators and electronic failsafe as well, depending on what you need in terms of features. So yes, the ZS260 is an explosion-proof housing that is available.
Okay. Someone cannot find the PDF mentioned in this webinar. I'm assuming you're talking about the 10-step worksheet that Nelson worked off of. It's in our PGPL, and it's also in the downloadable version of the PGPL and in the retrofit documentation.
Correct. And I believe it's in the retrofit section of the PGPL.
Correct.
So you have it's not in the front, a little bit further in the back.
Okay. Next question. 5-inch pound over feet squared, is this different for different manufacturers? Thank you.
Like I mentioned before, the numbers that we've been using, we showed here on that table, it's basically the norm through the industry that we've collected over the years and worked with our damper manufacturer customers in determining what your typical torque length would be. Now, depending on the design, like I said, it's the damper blade configuration, edge shields, and the air velocity that's going through it will affect your torque loading. So in most cases, if it's your typical, in this case, let's say your opposed blade with edge shields, that would not change. So the 5-inch pounds per square feet at less than 1,000 FPMs is typically that number. And that worksheet's been pretty solid. We haven't come across any scenarios where that number was either underestimating based on the information that was provided. But in some cases, we do discover like the airflow was a lot higher than we were originally told. So that's why sometimes the torque might have been not enough, so the actuator solution will have been changed out. But those numbers are pretty much solid, and like I said, we've been using it for a few years now, several years now.
Okay. I'm getting a couple questions in regards to when this webinar will be available or downloaded to the website. Just give us probably a day, and we'll have it up there as soon as possible. But if you are interested in getting it a little sooner, you can send me an email at marketing@us.belimo.com, and I can get it to you a little bit quicker. So the next question is, other than pounds per square feet ratings, why would engineers parallel versus opposed blades?
Well, it depends on the airflow characteristics that they're trying to achieve. Depending on the system configuration they're installing and trying to achieve in terms, like I said, the opposed blade versus a parallel blade. If you look at the airflow curve of the two dampers, you'll see that the curve on the opposed blade is a lot steeper versus a parallel blade. Just to put this in another way, the parallel blade will achieve almost max airflow at a smaller opening than an opposed blade would. So your airflow is different depending on which one you would use. Like say for a generator type application, parallel blade would be the way to go because you need air to come into the generator as quickly as possible. An opposed blade wouldn't achieve that. You would have to be at a higher degree opening to get more airflow versus our parallel blade type damper. So depending on what they're trying to achieve, like I said, it's application dependent. Could be due to, and also the damper authority they're trying to achieve as well. That takes into effect duct work, different filters that be down the system that changes the pressure, and also the airflow that's going through the whole system. So all that it should be taken into account. So it comes down to the application of which type of damper configuration they would use.
Okay, next question. Also, when we were choosing FPM or CFM, there was a listed WG. How do I convert it?
Water column, that's the water gauge, I'm sorry, that's static pressure. There is formulas, and depending on the condition, we could make this available. We don't have, unfortunately, I don't have this with me now. Obviously, FPM and CFM, just one's cubic and one's just linear, but the water gauge pressure can be determined through another equation, which we don't have, I don't have at this time, which we can make available, I guess, through another side note or a webinar, but I don't have that at this moment.
Okay. Does piggybacking two actuators on a jack shaft on a single section damper effectively double to torque output?
Yes. The idea here is when you piggyback actuators, you're getting more torque. Now, depending on the model, you are effectively getting double the torque. Now, for instance, if you go through a catalog, some on-off models, and we do piggyback them, and some of them are limited to two actuators on the same shaft. On our proportional models, you can go up to 3. You will have a derating of torque depending on the model. Most on-off models that you can piggyback, you do have a derating of torque. The reason being is versus the modulating actuators can be wired in master-slave and actually talk to each other. So these work in tandem and they track each other, so there's no torque loss. Now with the on-off models, since they're not really talking to each other, since there's no feedback connecting a master and slave, there's some slight derating to preserve life. So to answer your question, there is a derating for on-off models, and there is you say double or triple the torque on certain MFT models when piggybacked. Now, on the second side of this question here, wiring is important, like I was mentioning before. The on-offs are wired in parallel, so it's simple 2-wire on-off, power up, open, and spring close. But with modulating, wiring master-slave is important. So you're basically taking the feedback from the master and feeding them into the slaves. That way the slaves track what the master is doing and they move in unison. And again, like I mentioned before, you don't lose any torque in that sense. So you could MFTs program for on-off, and then you don't have any torque loss. Say for instance, an AF MFT. If you get 2 AF MFTs and program the master for on-off, then you get 360 inch-pounds with 2 AF BMFTs versus 266 inch-pounds versus 266 inch-pounds, I'm sorry, with 2 AFB 24 on-offs. So there is a difference. So if you really need double the torque, you will probably want to use MFTs.
Okay. What happens with the N4 enclosure if mounted in direct sunlight? The temp inside the enclosure could easily exceed 122 degrees Fahrenheit.
Correct. The NEMA 4 is going to give you the protection for environmental conditions, but heat, temperature is a different story. So it's going to protect against ice, rain, dust, dirt, anything else that can come in physical contact. But in terms of temperature, you're still limited to the temperature rating of the actuator, so that has not changed. The heater kit provides you to extend the cold temperature operation of the actuators, depending on the model, of course, if that heater is installed. So for instance, like the one I showed here was the AFB with the heater kit. We also have the EF. The EF has an incorporated junction box and heater inside the actuator. But the difference is one can go down to -49, the other one can go down to -40. So depending on the application and if temperature is concerned, yes, heat is a problem. For most commercially rated actuators, higher temperatures are always a limit. Uh, it's a combination of mechanical and electronics, but the electronics will probably start failing as things may start going awry. So heat is always going to be an issue, but that max temperature does not change in a NEMA 4 rated housing. So
Okay,
that's a good question.
great. 1 second. Do fire and smoke damper require a different calculation or a completely different seminar?
Well, torque loading is torque loading. I mean, you're determining how much torque is required to operate a damper. So again, if the application calls for some reason and a fire and smoke actuator, it still can be used. Now, fire and smokes are intended to be used for fire and smoke type applications. So the damper itself should be slightly different because it's designed to close shut in the sense of smoke or heat coming through the duct. So in terms of torque loading, that still applies, but in most cases, fire and smoke, since they are either pre-assembled onto the damper to be installed, or when it comes to retrofitting fire and smoke, yes, you'd still use the torque loading and use the properly sized fire and smoke actuator for that fire and smoke damper. So torque loading, like I said, torque loading is torque loading. No difference there, but it just comes down to the application.
Okay, great. We have a question in regards to PDH page, and are they accredited by the state of Florida and New York? So I can take that question. If you're looking for our PDH courses that we offer, you can go to www.belimouniversity.com, select the PDH course tab, and you'll find the list of 5 courses we presently have in our catalog. Yes, all courses are approved in the state of Florida and New York. And if you need any additional information about what other states are approved, you can send us an email at the Contact Us page on that website. Next question. Is there a worksheet for sizing damper actuators for new applications, or is it the same worksheet as the retrofit and replacement sheet?
Good question, and I apologize if I didn't clarify that at the beginning, but this works for both. This only takes into account the physical aspects of the damper itself in terms of construction. Damper blade configuration, edge seals or no edge seals, airflow. Now, there is a variation because new versus old, there's a difference. If it's a brand new damper being installed, it should be straightforward, and this damper actuator calculation is straight on. Now, with a existing installation, you have to take into other factors. What's the condition of the damper itself? In terms of retrofitting, we've come across numerous occasions where the actuators that we're replacing just gave out because over time, if the damper is not well maintained or just over time is just wear and tear, bearings start wearing out, there's a lot of grime and dust that builds up around the damper that causes the the dampers to seize up and create even more friction and opening and closing, then the actuators are on there may not have torque to open them anymore. So it could come down to just simple maintenance of the dampers, the existing dampers that is, that may need to be checked out before these new actuators are installed and replacing the existing to ensure proper operation and the actuators are not being overworked. In some cases, you may be reaching that limit, that torque limit of the actuator, and they may be working for some time and all of a sudden they just stop working. They start slipping off the shaft. In that cases, you probably want to look at the bearings, you want to look at the jack shaft itself. Sometimes they get warped. And also the maintenance, like I said before, the cleanliness. I mean, dust buildup, grime, all that stuff can cause problems. So there is a difference, other things to look out for when you apply this worksheet on new versus old.
Okay. How much torque on the actuator is considered too high for the damper? Say, as per the calculation, required torque is only 20 inch-pound-feet squared. What happens if 120 is used?
Well, the issue there is when it's During travel, so if you're moving the actuator from open to close or close to open, there should not be any issues, but it depends on the construction when you hit the end stops. If these dampers, depending on if it's a jack shaft or if you're directly on the linkage on the damper frame, if some of those linkages are not designed to withstand certain forces when it reaches its end stops, then there could be a problem where linkages may eventually wear out and the damper may not function properly. And in this case, you might want to go back to the damper manufacturer or just research the damper that you have. Like I said, sometimes you can't find the damper model, you can't figure out who the manufacturer is, but we do have different features in our actuators where we can limit the rotation. So during rotation is not an issue because you're just driving and opening, closing a damper. So you're not really, and if there's airflow, that's not a problem either. But it comes down to the construction. So like I said, running into the end stops of the dampers may damage them if the torque, the max torque rating of those linkages is exceeded. But like I said, on the features, well, going back to the features of the actuators, we do have limit stops on our actuators, mostly on the non-spring as well. On spring returns, you can limit the opening of the damper actuator. So say if you see that the actuator only opens up about 85 degrees and our actuators open up to 95-degree rotation, you can set that limit stop and prevent it from slamming into and driving into at the mechanical end stop of the damper. Our actuators are overload proof, so the actuators will just sense that it's hitting a external mechanical end stop and just stop working. But the damper itself is still taking that blunt of that force, especially at spring return. When your spring closed, those actuators are slamming back into its closed position. So it's another scenario where you have to be careful as well. So looking into the mechanical aspects of the damper, touching base with the damper manufacturer is also helpful in regards into what the limits are in those dampers and if the actuators may or may not cause any damage. And just to wrap this up, and in majority of our cases, we haven't not seen any issues in terms of the torque of the actuator being higher than the torque that's required to operate the damper. Only on certain models, on non-spring and electronic fail-safe, you can reduce the torque output. This is only through MFT, and it's an option through our PC tool software that you can hook up to the actuator. Spring returns, you cannot limit the torque because of the spring. Because once there's power, there's no more power applied to the actuator, then the spring is driving the actuator closed. So there's no way to basically tell the spring to slow down or put out less torque. It's fixed at that torque output. So if torque output is a concern, you could reduce the torque with the non-spring electronic failsafe. MFTs only, of course.
Great. So we have time for one last question, just due to time constraints. If you have additional questions, please feel free to email us at marketing@us.polimo.com, and we'll get back to you with those questions or answers to those questions. So Nelson, last question. What if you are unable to determine if the damper is opposed blade or parallel blade?
So if I guess the only way that not be possible is if you're not there or if someone cannot see the damper, because yeah, you're right, you might not have access to it depending on where the damper is, but if you're trying to retrofit, if you're installing actuators onto it, you should have access to the damper, and by simply removing whatever's on there in terms of like an existing actuator or something and operating it manually, you can see the movement of the damper blades. So of course, if you see the blades moving opposed to each other, then you know it's an opposed blade. If it's in parallel, they're moving in the same direction. So there should be a way to determine what kind of configuration you're dealing with. Parallel blade, obviously it's easy to know, but sometimes if you look at the mechanical linkages, sometimes when there's additional linkages on the damper blades, you can see the rotation, but the best way to do it is to operate the damper manually to see what kind of damper blades, or the configuration of the damper blades, and work from there.
Great. Thank you so much, Nelson, today for being our presenter, and thank you to everyone who attended the webinar. We appreciate you taking your time to listen to this great topic. And again, if you have any questions, feel free to email us at marketing@us.bluemail.com, and I hope you have a wonderful day. Thanks.